In this section, we'll be dealing with the physical and the chemical tests that are performed to get back to the ancestry of any skeletalized remains that have been found, and to get back to the dating of the skeletal remains or the fragmentary bones that have been found at any site. So the physical and the chemical tests basically involve the mainstay for these chemical tests basically is the strontium-90. Now, the strontium-90 was basically devised after the Second World War, and that is basically found in only the bones after that era period. So before that, basically, whenever we have a fragmentary bone that doesn't contain the strontium-90, it indicates that it belongs to an era before that Second World War. So that is basically a simpler method how we basically date a bone whenever we have it at our hand. And how are we going to basically physically identify the physical tests that are performed whenever we have the fragmentary remains? Because we have to identify whether they are the real human bones or they are the artifacts or the bones which are used for the teaching methods. So there are a lot of easier methods. The physical tests that can be performed, there can be a lot of naked eye examination methods that can distinguish between the real bones and the fake bones. And then we have also to identify whether it is a human bone or whether it is an animal origin bone. So there are a lot of tests that are devised for this method as well. This section deals with the physical tests, the serological tests that are performed, the strontium-90, and the identification of the carbon-14. So the fluorescence in the ultraviolet light is very important whenever we are talking about the physical tests that are performed for the identification of the bone. The recent bone shine with a silvery blue tint right across the whole section. So whenever we have a section at our hand, it will have a silvery blue tint, and that will basically highlight that it's a fresher bone rather than an older bone. As the bone ages, the outer rim creases to fluorescence, progressively deepen towards the center, and the fragments eventually vanishes along with the time period that has been passed on since death. The other physical tests that have been performed for these identifications are, of course, the density of the bones. Now, the density of the bones can be identified through the histological technique, and this is very important. This is the mainstay. We can get the slides onto it, and we can also identify it through the radiological examinations. For example, the X-rays can be devised for this method. Then we have the specific gravity measurements, and the bones are basically hit on to the specific gravity measurements to basically identify again the density of the bones. If it's a fresher bone, it will be more denser, and if it is an older bone, it will be less denser because of the loss of the collagenous matrix material, the osteoblasts, the osteoclasts are lost along with the time. So the ultrasonic conduction, it is also a method which is devised for measuring the bone density and will also indicate whether it's an older bone or it's a fresher bone in that case. The thermal behavior is again very important for the identification of the time since death that has been passed on after a certain time. And the environmental conditions, of course, they come into play in this as well. The serological and chemical tests that are performed for this identification are the strontium-90 and the carbon-14. As I've already emphasized on this factor, that if we find a bone with no strontium-90, it indicates that it belongs to the era before 1940s. That basically divides if it belongs to the era of 1950s, it will have very high levels of strontium-90 because it was then that the activity of the nuclear radiations took place in the atmosphere. So this is how basically you calculate what era the bones belong to. Then we have the carbon-14 at our hand, which is lost after death, and along with the passage of time, its basically concentration ceases with it. The positive test for the presence of the hemoglobin is very important on either bone surface or the powdered bone, and it partly depends upon the sensitivity of the technique. Now here you can see there is a slide which is showing the osteoblasts over here, and we have the osteocysts over here, And then we have the osteoids and the cement line that is found between the osteoblasts and the osteocysts. And then we have the bone, which is basically lying over here. So this is basically the histological slides that are formed after we get the cut sections from any bony remnants or bony fragments that are found at the sites. To measure the degradation of the proteinaceous stroma, it's very important, and to total nitrogen and the amino acid contents are then at our hand, and we can basically have it for the comparative studies from the human remains. The fresher compact bones have 4.5% nitrogen. So that has to be kept in mind. If we have concentration levels of nitrogen less than that, that means that it's not a fresher bone, and it basically indicates it lowers down, the concentration lowers down along with the passage of time. Now, if the bone contains more than about 4% nitrogen, it is older than 100 years. And if it has 2.5% or less nitrogen, it is likely to be older than 350 years. So these concentrations, these are basically the demarcation lines that are put over there, and we have to keep them in our mind as well. Now, the residual proteins can be converted to its constituent amino acids by prolonged heating in 6 microns hydrochloric acid, and they're digested, analyzed either by autoanalytical activity methods, by two-dimensional chromatography methods which were devised. The fresher bones, if we basically compare them with the older bones, they have their own characteristics. The fresher bones contains 50 amino acids on one side, which is compared with the older bones. It has proline and hydroxyproline, which vanishes about 50 years after the death, mostly derived from the collagen. And on the other hand, the older bones contain only 4 or 5 amino acids relatively of the ancient time. The fresher bones, on the other hand, contain the glycine and alanine predominantly. When we talk about the fresher bones, it's basically the proline and the hydroxyproline, more specific markers for the collagen, and the glycine persists for the millennia, being found in the Paleolithic material in the older bones. So this is basically the comparison that basically highlights the effects of the presence of a lot of amino acids which are found in the fresher bones rather than in the older bones. So these have to be kept in mind, and whenever we find a bone, whenever we have bone at our hand, and we have to indicate whether it's a fresher origin or it is from an older origin, a lot of things come into play, and we have to basically, they have their own scores at that level. So the teeth are also very important, and this is a normal architecture of the teeth that is found. It has a crown, a neck, and then we have the root at this point. So the estimation of the racemization of the amino acids in teeth is also very important. The ancestry can be drawn through the teeth examination, and it changes linearly with the postmortem interval. So the postmortem interval can also be identified through the physical characteristics of the teeth, and the chemical tests can be performed for these teeth. The changes basically that occur depend upon the environmental conditions again. Now, the other biochemical and the chemical tests that are performed are the X-ray diffraction of the crystalline structure of the bones, the decomposition byproducts that are found after the chemical test performed, the amino acids and the citrates as well come into play, and then finally we have the luminol techniques that are basically the serological test. The presence of the bones is indicated by this method. Luminol technique is basically a technique which basically it measures the chemiluminescence by the luminol reaction. It is basically the 5-amino 2,3-dihydro-1,4-thalaziodine. This is basically which causes the luminosity after we spray the chemical. So it will basically indicate the presence of the blood with the osteophytes and the osteoblasts. For detecting the blood residuals in all sorts of substrates, it's very important. And the bone is ground into a finer powder, tested for luminescence by mixing with a small amount of luminol. It's very important. So as again I've already emphasized on the presence of the strontium-90 and the carbon-14 which is found and it basically indicates the era to which the bones belong. It is basically the radiochemical testing. The radiocarbon tests are performed, and it measures the loss of the carbon-14 after death, basically, which vanishes. And the strontium-90 again basically marks the era of the World War II. It's very important. So its levels basically determine to which era the bones belong to. So in this section, basically, we discussed the importance of the physical and the chemical test that is performed to identify whether the bone is of human origin, and if it is from the human origin, what is basically the time since death and to which era these bones belong to. A lot of physical and chemical tests are performed, and they have their own significance. That was the end to this section. Thank you for watching sqadia.com.